Alright, so let's talk about chapter 16, which will be on climate change. Alright, so historically, let's start off historically by showing you what has been documented about climate change in the past. And in Earth's history, there have been periods of warmer climate and cooler climate compared to today's climate. So today, I would say it's pretty warm, but there have been times in Earth's past where it has actually been warmer than it is today, and there have been times where it's been colder. Usually the colder periods are associated with ice ages, and climate change in the past has primarily been dominated by natural processes. So we will talk about what these natural processes are in a little bit, in a few more slides. But currently, our climate change that we're experiencing right now is primarily due to human activities, and we'll see why that is in a little bit. So you can see some of the images in this slide here. On the left-hand side, there's drought. So some places are experiencing more drought than usual, so less rain. You can see on the right-hand side there's an image of deforestation occurring, where they're burning down the trees in the forest to make room for grassland so that they can feed the cattle. And the middle image right there is showing you industrial power plants that are releasing gases into the atmosphere. So we'll talk about all of that in this lecture. So before we continue on with current climate change, we have to really understand why climate change is such a problem and why it's even happening in the first place. And the reason why climate change is the way it is because our climate system is made up of 5 different parts, and they all interact with each other, and they all influence each other to some varying degrees. So the 5 different parts of our climate system is the atmosphere, which is the air that we breathe, the hydrosphere, which is the ocean. Hydro just means water. The lithosphere, so the earth, so anything soil or terrestrial related. The biosphere, which is the animals and the organisms that live within the earth, and so bio means life, right? And then the cryosphere. The cryosphere is the glaciers and the ice at our polar caps. So you wouldn't think that has any impact, but you'll see why the glaciers and the ice caps are part of the equation in a little bit. But exchanges of energy and water between all 5 of these parts occur on a regular basis, and depending on whether you have more or less energy or water transferring between each part will determine whether we have a warmer period or a cooler period or just a normal warm period. But yeah, so whatever changes are made in the atmosphere will likely affect the other 4 parts. So let's look at this graphically. Here you can see the ocean. The ocean would be your hydrosphere. Then in the atmosphere, where you have your clouds and your rain, there's interaction between that. Then up on the mountains, you have your cryosphere, where you have ice and glaciers. And then your biosphere is typically on land, although you do have a biosphere in the ocean. And then you have your lithosphere, which is your earth. And so all of them are interconnected one way or another. Okay. So let's look at how, in particular, the atmosphere is connected to the ocean. And one way that you can see that they're connected is by looking at the feedback loops. Now, feedback loops are processes that change the initial conditions And when you change the initial conditions, you can either have a positive feedback or negative feedback. And in this image right here, it's showing you the positive feedback that's occurring over the ocean. And then over land, you'll have a negative feedback that occurs above the cloud, but then you'll have a positive feedback that occurs below the cloud. So what's going on here? So essentially, you have heating that occurs on the Earth's surface, and when that heating occurs over the water, it causes the water to heat up, turn into water vapor, and go into the atmosphere. And when that happens, the water vapor traps in the heat that would otherwise escape into space, and you create a warming effect. So your initial condition will be warming, right? Because you're warming up the surface of the water and you're creating water vapor, and your end result will enhance the initial condition. So you continue to warm in a positive feedback situation. Whereas in a negative feedback situation, your initial condition is warming, but then that water vapor condenses and turns into clouds, and those clouds then block any further sunlight from reaching the Earth's surface. So in that sense, you have a negative feedback. So there's a cooling effect in that sense. Um, you do have a slight positive feedback underneath the cloud because it does trap heat, but the overall effect is a cooling because you don't have that additional sunlight coming down and heating up the Earth's surface. So let's go back to climate change. Now that you understand a little bit more about the climate system and how they're interconnected, but I pose this question to you: what is real? Because when you go and do a Google search of climate change and global warming, you get probably a gajillion articles. Some of them say, yes, global warming is a thing, global warming is happening, while you have others who say, no, global warming is just something that the scientists made up. It's a political move, blah, 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 so forth and so forth. All right. But how do you know which article is true and which one's not? In this comic here, it illustrates over time throughout history different theories that have come about and the type of arguments that people would say about that particular theory. So in the 15th century, you have people who are saying the Earth is round, right? Because they're looking at they're looking at astronomy and they're looking at what's going on, and they're fairly certain that the Earth is round. But then you have those other people who are naysayers, right? And they believe that the Earth is flat because that was the prevalent theory at the time. So the theory that the Earth was round was a new theory back in the 15th century and was highly regarded as hearsay and like speculation, and really people who were trying to convince the population that the Earth was round were crazy, or at least that's what they were led to believe. But in reality, we know the Earth is round, or at least my opinion is that the Earth is round. Not quite sure what your opinion is. But if we continue on into the 17th century, you can see, not Einstein, what is his name? Newton. Is it Newton? I think it's Newton. But anyways, the scientist who says, is gravity real? Explain this, right? And so you see a bird flying, right? So theoretically, if we didn't have gravity, how is the bird flying? So again, you see that there's always two sides to an argument. You know, there's one side that's like, no, I'm pretty sure this is a thing. But then there's another side that's like, well, no, there's no way this can be a thing because X, Y, and Z. So over time, you can see it has happened time and time and again. And even in the 19th century, where you have evolution, right? But then you have people saying, well, what about the Bible? Blah, blah, blah. Until you get to the 21st century, which is now, and you say, well, how is global warming real if we still have snow? So the main point of what I want to get on this slide is, while there's always going to be two sides of an argument, one that says, yes, this is a thing, and the other that's going to say, no, this is not a thing. Throughout this lecture, I want you to look at the facts and make your own decision. Don't just take my word for it and say, well, Professor Nathan said that global warming is a thing, so it must be a thing. Or if you read in the news nowadays and Trump says, no, climate change is not a thing, it's just made up, blah, blah, blah. Well, try to figure out and do a little bit of research why they're saying that. Because who knows, maybe your opinion will change on the matter. But in this lecture here, I'm not trying to convince you of climate change. I'm just trying to give you the facts and how it relates to the ocean. So you can make your own opinions, all right? So how have we determined the climate in the past? And what we have done, since we weren't there to take data, is we've done what's known as proxy data sources. Proxy data just means that we have taken our information from a secondary source. So while we don't have instruments in the past to tell us what the climate was like, we can look at such things like tree rings, for instance, to tell us what the climate could have been. Now, this is not an exact data source, so it's not going to tell us, oh, well, you know, in 89 AD it was 79 degrees average temperature. No, it's not going to be that. What it is going to tell us is whether there were periods of dry times or whether there were periods of wet times, or cooler or warmer times, just depending on what the information is. So let's go back to that tree ring example. If you see the image on the right hand side there in the middle, you can see in the middle, that's where the tree started off. And as you expand outwards from the middle of the tree rings, the first set of rings in the middle there are very wide or distantly spaced. And you can infer from that the tree had enough water and enough nutrients to grow throughout that year. So it was able to grow quite a bit. And it had favorable conditions. Whereas if you see on the outer edges of the tree ring, the rings become closer together, right, and much thinner. And those time periods you can anticipate being non-favorable conditions. So maybe there wasn't a lot of water, maybe it was a drought season, and maybe it didn't have a lot of nutrients. So instead of growing, that plant conserved its energy and put it elsewhere, right, instead of growing. Another way to determine past climate is by looking at seafloor sediments. And in seafloor sediments, you can see changes in the sediment composition. So you can see if there's a lot of calcium carbonate, so maybe there was a lot of productivity, or maybe you can see a lot of biology. And in that case, you can see that they were favorable conditions. Otherwise, if you just see a lot of byssal clays or ash maybe, then maybe it wasn't favorable conditions, all right? But again, you're not going to find of specific temperatures. You're just going to find generalizations. Another proxy data source would be bubbles trapped in ice. So you can see that ice core on the bottom right hand image there, and you can see the different layering that occurs within that that ice core there. And there's that really dark band in the ice, and you could probably infer that it may not have been favorable conditions when that time period was around, because usually something dark like that would indicate a lot of ash or a lot of dirt in the atmosphere, and so probably there was probably a huge eruption at that point in time, whereas the other parts of the ice core there that are clear and more white in color, those are areas where you have a lot of oxygen, probably favorable conditions. So definitely not a super warm period and not a super cold period. Next, you have fossilized pollen. So the top right-hand image there is that of fossilized pollen, and you can see there's all different shapes and sizes depending on the plant. But fossilized pollen can be used to see whether it was favorable conditions or not. Because if a plant is in rough conditions, doesn't have a lot of light or doesn't have a lot of water or nutrients, it's not going to produce as much pollen as if it were in favorable conditions. So essentially in sediment or soil, if you see a huge quantity of fossilized pollen, then you know that then it was a favorable conditions. Coral reefs, you can actually cut them in half, much like a tree ring, and they actually show rings in their skeleton, so you can see like whether it was favorable conditions by looking at the rings in the coral as well too. Cave deposits, basically your guano. But essentially, if it's favorable conditions, you can see large amounts of